So at the top of 10.2, you'll see this diagram. It says tell what the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. When you look at these words, which of them are segments? So just these words. Which one? The radius is a segment. What else is a segment? A chord, and then what else? Diameter. So radius, chord, diameter are segments, which means which of them are lines? Secant and tangent. Okay. A radius is a segment. It goes from where to where? Center to the edge. Good. Chord goes from edge to edge. And then the diameter goes edge to edge, but it's through the center. A secant and a tangent, they're lines. What is the difference? What does a secant do? Touches a circle twice, and a tangent touches a circle once. Okay, so PR, this first one, it is a segment. So it starts at P and ends at R. Okay, is it best described as a radius, a chord, or a diameter? It is a diameter. MN, it is a line. How many times does it touch the circle? Once, which makes it tangent. PQ is a line. How many times does it touch the circle? Twice at P and Q, so it makes it secant. Then last is QO. It is a segment. What would we best describe QO as? Radius. Something to remember with tangents is remember the point of tangency. What is the point of tangency in this circle? Yeah, it's R. So it's where the tangent line touches the circle, which would be R. Okay. It didn't ask for it, but just as a refresher. We've got these three questions, which review 10.1. The first two, you have to remember the property we talked about yesterday, and it is that the tangent line and the radius, they had to be something. What was it? Perpendicular. So it must be perpendicular. So in the first question, we've got is DE tangent. So I always write which line is tangent or possibly tangent. Just helps me figure things out. So is DE tangent? The tangent line and the radius would have to be perpendicular. Which of these segments is the radius? 3, yeah. CD is the radius. So if DE is tangent, there'd be a right angle right here. So the reason I had you take out your 10.1 notes for a second, go to page 2 and look at the difference in the problem on page 2 and this problem. So the difference in the way that it's drawn on page 2 of 10.1, it says that this bottom, like TP or SP, is 37. It showed you a bracket to show the full length is 37. Whereas here, you're given the number 2, but do you see a bracket? You do not. You also don't see that CE's length is 2. That's because it is not. It means this portion is 2. So we need to figure out what the remaining portion of the line is. So you will have a question like this on your quiz next week. But here's what to remember. What do we call a segment that goes from the center to the edge? Call it the radius. The radius is the same all the way around, so it makes a circle a circle. Do we know the length of the radius? Yes, what is it? 3. So what is the full length of CE? 5. Okay, so keep that in mind when we go to do what we're going to do. We want to see if DE is tangent. In order for it to be tangent, this needs to be a right angle, which means DEC needs to be a right triangle. So how can we tell if this is a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. So which of these numbers will be A and B? 3 and 4. which means 5 will be C. I told you all a long time ago, what is the most common Pythagorean triple? 3, 4, 5. So this is definitely going to work because 3 squared is 9, 4 squared is 16, 5 squared is 25. Does 9 plus 16 equal 25? It does. So yes, this is tangent. And if it ever asked you to explain, if it ever said it, your explanation is that the tangent line and the radius are perpendicular. That'd be that. All right, and the next one, ST is tangent. So ST is tangent. Find the radius of circle Q. So we want to use this property again. The tangent and the radius must be perpendicular. So the tangent and the radius will intersect and form 90 degrees. This is important to note so that you know that RT is the hypotenuse. So what is the full length? Sorry, QT, not RT. QT, what is the full length of QT? Which one?
Oh, 20. We don't know, right?
We don't know, but what would we call it?
18 plus R.
Correct. 18 plus R or R plus 18 would be the same thing. So the full length will be 18 plus whatever the radius is. We're still going to use the Pythagorean theorem. A squared plus B squared equals C squared. So which of these sides is going to be A and B?
24 R.
Correct. So 24 and R equals, and C is, we said 18 plus R. How do I show that I want the whole side to be squared? Put in parentheses, the squared on the outside. We're going to do the left side first. R squared plus, what is 24 squared? 576. Equals, so when something's being squared, it's being multiplied times itself. So this is 18 plus R times 18 plus R. We are going to end up distributing here in a second. I'm just dropping the left side down. We're going to distribute. You call it foiling if you want to, but you just distribute 18 to both things in the other parenthesis and R to both things in the other parenthesis. So starting with 18, 18 times 18 is 324. 18 times R is 18R. R times 18 is 18R, and R times R is R squared. So R squared plus 576 equals, we got 324. What is 18R plus 18R? 36R. And then plus R squared. So what is the next thing that we would do?
We can combine like terms. Oh, no.
Right.
And subtract the 324.
We can. What do we want to do before that? Yeah, the R squared. We could subtract them, cancel them. So those are gone. And then, yeah, we can subtract the 324. And what do we get?
252.
252 equals 36R. Divide by 36. And the radius is 7. You could say units if there's not a unit. That's that. The last one is number 8. So M and N are points of tangency, which means they are two tangent lines that intersect at the same point, which then means the two tangent lines are congruent in length. So here's what's going to happen. X squared will equal 9, but I want you to pause before you solve it, because you're probably, well, some of you are in Algebra 2 though. How many answers are there in a problem like this? One answer, right? In a problem like this, where there's a squared, there's going to be 2 answers. In a problem where there's a cube, which is to the third, there would be 3 answers. The highest exponent is how many answers there will be. So in a squared, we are going to use the property we know. We've got x squared equals 9. How do I get x squared by itself? Take the square root. But there are two answers when you take the square root of something. There's the positive and then there's the negative. So, because, what's the square root of 9? It's going to be 3. It's going to be positive 3 and negative 3. This is the way we write it in upper math. We write positive and negative in the same spot. This is because if I took this length of x squared, and I plugged in negative 3 squared, what is negative 3 times negative 3? Positive 9. Okay, so it's both the positive and the negative. Okay. All right, so we are ready for 10.2. That was all review. We're going to talk about 10.2. It's about finding arc measures. This whole chapter is about circles, and my favorite type of circle is a pizza. So today we're going to be talking about the crust of the pizza. So I'll give you like a little idea of it. You cut a pizza like this if you're a sane person. When you cut it like this, there are angles, right? You'd cut it into 8 different angles down here. Angles, these would be called central angles, and we'll talk about why in a second. They correspond with the arc that's made by the rays, okay? What you're going to find is that whatever measure this angle is, the arc will be as well. That's this section. We're going to learn some terms, and then we'll go from there. So today, we're going to find arc measures. Tomorrow, we'll do the last two. Identify congruent arcs, and then prove that circles are similar. Okay, so before we do, we're going to talk about central angles. I said the word, you don't know what it is. You're going to write it on your paper. It is an angle with a vertex at the center of the circle. So however you want to write it, it is an angle with a vertex at the center of the circle. It is an angle with a vertex at the center of the circle. It is an angle with a vertex at the center of a circle. And then you're going to draw it. So you see the center of our circle. You've got a circle mapped out. Here is the drawing that I have. You would put A, C, B. The center is C, so this would be circle C. This is broken up into 2 arcs, and we're going to talk about the types of arcs that there are. That's why you have 2 highlighters, hopefully, because we're going to talk about them. There's what we call a major and a minor arc, and we're going to talk about them now. A major arc, I just want you to write that it is between 180 degrees and 360 degrees. So a major arc is between 180 and 360. A minor arc is less than 180. So a major is between 180 and 360. A minor is less than 180. Why does 180 matter in a circle? It's half, right? The whole circle is 360, 180 is half. So if it's less than half, it's minor. If you ate half of a pizza, less than half, it's pretty minor. If you eat over half, it's pretty major. Just kidding. You're going to draw these letters in your circle, if you haven't already. We're going to name the minor arc and then the major arc. So we're going to do it in a little bit different of an order. But go ahead and highlight the minor arc. So I highlighted mine in yellow. Whenever you name a minor arc, the symbol for an arc, it's an arc, and then we would put 2 points of the arc. So the start and ending point of the arc. So what would I name this arc that we just highlighted? Arc AB. You can reverse it and say BA. Both are correct. A major arc, which is over half, a major arc, you use 3 points. So, if we wanted to name, you can do a different color. Highlight the major arc. It's the remaining of the circle. If you want to name this one, it does matter the order that you go in. You can start at either end. So, we could start at A, just to make it easy. The arc starts at A and goes in the direction of what letter? D, and then ends at what letter? B. You can reverse it and say B, D, A. but you got to make sure that you go in the correct order. A, D, B, B, D, A. Okay. So this is how you name them. If it's got 2 points, it's a minor arc. If it's got 3 written under, it's a major or even a semicircle, which we're going to talk about next. So if a major is more than 180 and a minor is less than 180, what do we guess that a semicircle is? Is 180. So I want you to write a semicircle is 180 and it is formed by the diameter. So a semicircle is 180 degrees and formed by a diameter. Sorry, I lost track. So a semicircle is 180 degrees and it is formed by the diameter. So I think you have this picture. Go ahead and write down all these points. We're just going to name them. So let's name the top semicircle first. You name it the same way you name a major arc. You draw an arc and you do 3 points. So do we want to start at A or B? Sure. A. So we A and in the direction of C and ends at B. So it's A, C, B. You can reverse it to B, C, A. If we wanted to name the bottom, clearly I'm very good at drawing arcs. You're welcome. If I wanted to name the bottom, do we want to start at A or B? Sounds good. A, and it goes in the direction of D and ends at the letter B. And again, you could reverse it if you choose. B, B, A, same thing. All right, you can flip to the next side. This next portion is not on your notes, but it's just we talk about it because I've already kind of said it. The measure of a minor arc is the measure of its central angle. So pick a number between 1 and 180 that this angle could look like. 78. So 78. Sounds good. So if the central angle is 78, that means that the arc is also 78 degrees. So that's a minor. A major, there are many ways to find a major arc, but if you're only given the minor, we're going to make it easy and round up to 80 because we're about to do something with it. If the minor arc was 80 and I wanted to find the measure of the major arc, how many degrees are in a circle? 360. I already know there's 80 degrees taken up, so what would I do to find what remains? Subtract. So I do 360 minus 80, and we would get degrees. Okay. So we're going to use that on the, I think it's page 3. Find the measure of each arc of circle P, where RT is a diameter. Anytime you see the diameter, just highlight it. So I'm going to take a second and highlight the diameter. This tells me the circle has been cut in half, which means the top half is 180, but it also means the bottom half is 180. Okay, so it's just something easy to remember. You can label them as 180, 180, or you don't have to. We're going to do A, which is RS. It is 2 letters, so I know that this is going to end up being a minor arc. Okay, RS. So we're going to start at R and go in the direction of S. You need to go directly to S. Do not pass go. Do not collect $200. You need to go to the shortest distance between R and S because it has to be minor. So am I going to go up around the circle or down around the circle? Down. And end at S. So how many degrees is RS? 110. It doesn't ask, but whenever you go to do your whiteboards in a second, it's going to ask. This is a minor arc. If you just want to be in the practice of it, you will have a section where you have to tell me it's minor, major, or semicircle. Next one is RTS. So we start at R, then we go to T, and we end at S. So am I going to go up around the circle or down around the circle? Up. R towards T and end at S. There are technically 2 ways to figure this out. What is one of them? Subtract 360 or subtract 110 from 360. And then what do we get? 250. Which means this is major. The other option, and my last class, some of them preferred it. How many degrees is the arc I just highlighted, this yellow one? is 180. So then this piece, if this is 110, 180 minus 110 means this one is 70. And then 180, you could have added them and you still get 250. All right, the last one would be RST. So starting at R, going towards S, ending at T. So do I want to go up or do I want to go down? Down. Go towards S, end at T. How many degrees is this? 180, which means it is a semicircle. All right. This is not on your paper. We're just talking about it for a second. Adjacent arcs are arcs that are right next to each other. They share a wall. You can add them. So if, let's say, we said 80 earlier. Let's say this angle was 80 and this angle was 20. And I wanted to find the measure of AD, arc AD. What would I do to find the measure of arc AD? You'd add them. So 80 plus 20 means the measure of arc AD would be 100. So we're going to use that here. We're going to find each arc. GE, it's 2 letters, so what kind of arc is it? It's minor. So we start at G, we want to go directly to E. So am I going to go left around the circle or right? To the right. End at E. 40 plus 80 is 120. All right, G, E, F. So starting at G, going towards E, ending at F. Am I going to go left or right? Right. To the right. G, E, end at F. So to figure this out, we just add 40, 80, 110. What do we get? 230. Last is GF. It is a minor arc, so we want to go from G and go directly to F. Am I going to go left or right? To the left. So again, you can figure this out one of 2 ways. Nope, there's only one way. There's just one way. You just subtract from 360. What was 40 plus 80 plus 110? 230. So subtract 230 from 360 and we get 130. Good. Boom, boom, boom. You're going to try this one on your own. So NM, it's a minor circle. What did you do to find the measure of NM? It is 55. You add them all, and then what? Subtract from 360. If it's 55, it is minor. All right, and then JLM. So starting at J, going towards L, ending at M. Add all of those together, and we get 245, which means it is major. NLK, starting at N, going towards L, ending at K. How many degrees is this one? 180, which means it is semicircle. And then last, LMN. I know it is 2 letters, so it is minor. It's 3 letters. You can name a minor arc with 3 letters. It is not preferred. Name it with 2. It is minor, though. We said this one was 55. So what is 55 plus 65? 120. Okay, we got one more to do together. And then we play the booklet, I believe. You might get further because you're honors. A recent survey asked teenagers whether they would rather meet a famous musician, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So, it's on the notes. We're going to do it together. This is the same we've been doing. It's just got colors and words with it. Our project, whenever we do this, we're going to do a survey project, and you're going to end up making it into like a chart like this. You're going to survey people around you. So you'll make something like this eventually. We're going to find the measure of arc AC. Measure of arc AC. So this is minor, so we want to go from A directly to C. So am I going to go up or down? Up. So A towards C. So we can add 29 and 108. What is 29 plus 108? 137. A, C, D. So starting at A, we want to go towards C and end at D. So we're going to go up or down. Up, A, towards C, end at D. You can add, you already know what 29 plus 108 is. Just add 83. And we get, correct. A, D, C. Starting at A, we're going to go up or down. Down towards D. And then to C. So we're going to add 83, 61, and 79. So what do we get?
223.
223. And then E, B, D. Starting at E, we want to go towards B and end at D. So am I going to go left or right?
Left.
Left. So E towards B, end at D. You can add all those numbers up. What is option 2?
360 subtract 61.
Correct. 360 minus the 61 that's not included, and you'd get
299.
299. We do have time for one more whiteboard. It's just going to look like this. So you can put away your notes for now. So a recent survey asked high school girls to name the sport they like to watch the most. The results are shown in the circle graph. Find each indicated measure. Check the last one. The first one is wrong, but the rest of them are good. Yeah, now you're good. Correct. Last one. Sorry. Yeah, last one. That's good. Good. Alright, so we're going to talk through it so that I can finish the recording. FG, the length of FG is 32. EGB. So E towards G, end at B. Am I going to go up or down around the circle? Up towards G and end at B. Add 40 and 32 and 28 and 108 and you get 208. DB is a minor arc, so we start at D and we go directly towards B. So you add 51 and 54, which makes 105. And then last ACE, starting at A, go towards C. So am I going to go left or right? To the right, towards C, and at E. Add 108, 54, 51, and 47, and you get 260.